starting with the one we've just finished, and that's solving equations. Won't spend too long on this one because we've gone through it a number of times. Yeah, voluntary if you want. You can. But I'll be going through all the key skills now that will come in the exam. So solving equations, I'll do one example. I'll try and do at least one example question for each one. So the question will read, the keyword you're looking for is solve. And you might be given something like this. Okay. We'd be asked to solve an equation like that. Solving an equation means that at the end of this, we'll have x equals the end of solving an equation. Okay, so we did a number of these yesterday. You seem to be pretty good at them. I'll briefly go through it. The steps are, when you get to this stage, do the opposite and then balance both sides of the equation. So if I'm dividing by 7 here, subtracting 8 here, and I'm multiplying by 3, I need to do the opposite of those 3 operations to get there. What number should I get rid of first? The 3, the -8, or the 7? Which one do you think, Alexis?
7.
Yes. So if they're both divided by 7, get rid of the 7 first. By multiplying both sides by 7, because that's dividing by 7. Because 7 fits into 7 once. You multiply by 7, divide by 7. That's just the same as multiplying by 1. I'm left with 3x minus 8 is equal to 2 times 7, that's 14. And now it's a two-step equation, so I need to get rid of -8, so I would add 8. It's the opposite to both sides. Draw a line underneath. The 8s will cancel, that's the point, a bit like the 7s will cancel here. -8 plus 8 is nothing. I have 3x's remaining on the left side. 14 plus 8 gives me 22. So 3x's are 22. I only want what 1x's. So I divide by 3, because multiplying by 3, the opposite operation is dividing by 3. X, 3 fits into 22 how many times? 7. What's my remainder?
1.
So it's a 7 and 1/3. That is the answer. Now, there are other types of solving equations that include brackets. We went through those the other day. Multiply the brackets first, or if you have to simplify, simplify first as well. Or if there are variables on both sides, you need to know how to do that one as well. And there's examples of that. We've previously done loads of those. That's solving equations. Let's move on to the second one, which some of you may have forgotten. That is factorizing. Okay, so factorizing, we'll do an example question. For this, you are looking for the keyword factorize fully. You see that? That means this is a factorized question. I'm going to do 6x squared y. I'll just change pen. 6x squared y, this would be a difficult example, plus 12x, let's see, plus 18xy. So 3 terms, 1, 2, 3 terms. That would be what the question might look like. For the answer, well, factorizing is the opposite to expanding. And if we remember expanding, if you have something like 2 times x plus 4, I multiply to get my answer. 2 times x and 2 times 4. Now factorizing is working back to getting the bracket. So I need a bracket in my answer. I need, and outside the bracket goes the highest common factor. What is the highest common factor of these 3 together? Maximum, what do you think it is?
6x.
You think it's 6x?
Yes.
Okay, let's go through the process. What letter is in all three? X. There's y in these two, but not in the middle one, so that doesn't count. So x is definitely common. Well, it's a common factor. And what number then divides into 6, 12, and 18? 6. So we're saying that 6x divides evenly into all these three, as it is a factor of all three. And it does. We need to figure out now what's left behind in the bracket. A bit like if we factor out 2 out of this, what would we put in the bracket? Put a plus there. The signs won't change. In this example, we have the answer, but we go 2 times what gives 2x, and we go 2x. 2 times x gives 2x. And 2 times what gives 8, gives 4. That was that simpler example. Now this one is a little bit trickier. 6x times what gives 6x squared y? Oliver thinks it's xy, and he's right. Because x times x gives x squared, and 6y would be the 6y part. Lucia, what's the next one? 6x times what gives 12x? 2, yeah. And the last one then, Bastian. 6x times what gives 18xy? Be 3 anyway, yeah. 6x times 3 gives 18x. What am I missing, Oliver? Y. We need that y as well. 3y. Is this my final answer?
Yes.
Max is sure, and he's right. That is the final answer. That's as much as you need to do. Get the highest common factor outside the bracket, and then what is left behind inside the bracket. Remember, you can always test by multiplying back out, and you should get this again. That's factorizing. Now that'll be a relatively difficult example. You could be given one as simple as this one, 2x plus 8, factorize, and then it'd be x plus 4 in the bracket of 2 outside. That is a simpler example. Okay. So hopefully you remembered factorizing. Maybe you did, maybe you didn't. Let's move on. We're going to get through all of these in one big notes if you're taking notes. So the next one we're going to do is simplifying. 3 is simplifying. I'll do an example question again. So simplifying is about collecting terms. Okay. So at the end of this, will I get an x equals? Scalar? No. Because there's no equal sign. So what happens a lot, people trying to solve this, even though there's no equal sign. Can't solve something unless I know what it equals. So I could just, I may say tidy it up, but simplify it is the right word. At the moment, there's 1, 2, 3, 4, 5, 6 terms. Some of those terms can be combined, added, or subtracted. So add or subtract, depending on the sign, like terms, ones that can be put together. Okay. So I have 8 minus 4 and plus 7. They all can be combined because they are constants, which are numbers. What would that total be? 8 minus 4 plus 7. Rebecca? Well, okay. 8 minus 4 gives 4. 4 plus 7 gives 11. Yes. Does it matter what order I do these in? Do I have to put the x's first or the numbers first?
Yes, we have to put the numbers.
No, it actually doesn't. You can put it in any order. It'll be the same answer either way you want to do it. Charlie?
Is before negative?
Same.
It's just minus 4.
You can treat it like a treat it like a subtraction of 4, or you could say, okay, it's -4 and you add -4, 8, and that's still a minus. Either way, you get the same answer. All right. Let's look at the x's. Is this an x? Is this one of these? No, I think. Well, maybe we'll just write that answer then. Plus 3xy. Can I just put that in the answer because it's nothing to simplify it with? Yeah, I can. That's the one on its own. There's no other xy's. He's got no friends. I know, it's tough. 2x, take away 4x then is the last one. Minus 2x, very good. And that's my answer. Once again, there's no x equals at the end of this. I've just tidied it up a little bit. And that's it. So all I need to do is add or subtract the like terms based on the sign in front of them. That's simplifying. Often that comes with expanding, using the distributive rule, which we'll do now.
Yeah, like yesterday, you told us to first expand then simplify.
Exactly, yeah. So
simplify and then expand.
don't try and simplify and expand at the same time, because that gets becomes messy. So 1, 2, 3, 4. Oh, wrong color. Expanding. Using the distributive rule. And often when you expand, you end up simplifying as well. And that's what we're going to have in our example question.
I have a question.
Yes.
Did we first do the 6 minus 2 or the 2 times x times 2 times?
So this question would ask to expand, I didn't put in the keywords, and simplify. Expand and simplify. Okay. Good question by Maxim. He wants to know, do I do 6 minus 2 first, or I do the multiplication first? Is that it? Yeah.
Yes.
Which do you think it is?
Maybe I have to do the multiplication first. It's in the bracket, but.
Bastian definitely think so. He's nodding away. Yeah, you multiply first before any adding and subtraction. Unless the adding and subtraction is in the bracket. These two, can these be combined to say 3x?
No.
No, definitely not. X plus 3 is not the same as 3x. So they just have to be separate. They're not like terms, can't put them together. So my next step would be to expand, which means multiplying this -2 into the brackets and this +7 into the brackets as well. Remember to take the sign. So I'm multiplying by -2, +7. So the very first thing I'm going to write down is when I expand, and this is using the distributive rule, but that word won't come up in the exam, but this is what you're doing. Charlie? Oh, that's what I'm, yeah. So the 6 is just 6. Nothing to affect it in the expanding process. I might be able to simplify with this 6 in a bit, but if I want to expand first, which is what I want to do, it's on its own. -2 times x gives -2x. That's not too bad. What's my next term?
3, but it's plus minus, so it's a minus.
3?
No, it's 6. Well, 2 times 3.
Okay, yeah, it's 2 times 3, so 76. It's a minus times a plus. Remember, this is a multiplication, so it's a minus. Minus times a plus is a minus. Now we have +7 times 3x, so that's going to be plus what? 21, yeah. Are you with me? Yeah. +7 times -1, -7. Plus times minus, minus. That's it expanded. Now I simplify. Yesterday, I think definitely Maxim's group, but I don't know, a couple other groups did. They tried to simplify and expand simultaneously, as you said, at the same time, and it just got all sorts of wrong. Trying to swap sides and simplify didn't work. Okay, so let's simplify. Let's do the constants again first. 6, take away 6, take away 7. 6 take away 6 leaves me at 0. 0 take away 7 just brings me back to negative 7. Negative 2x plus 21 of the x's. Positive or negative? Yes, a positive 21x, take away the 2x, be 19. Does this equal something then? Can I solve it? X equals? Nope. Once again, you're looking for, if the question says solve, that means there's an equal sign and you can actually get an answer for x. If it doesn't say solve, you can't get an answer for x.
So if it says solve, we don't find out what the answer of the whole question is. We just find out what x is.
Yes.
Oh, okay.
If you see the word solve, the question is going to have an equal sign in it. Because it'll say what it's equal to. So solve it. This at the moment is just tidying up and simplifying. Okay. And that is expanding using the distributive rule. Formula creation and number patterns, number 5 and 6. I'll do them separate. But they are linked. 5. Okay. So formula creation. The question will come in usually a few parts. It might ask to draw the next shape. Draw a table, and I'll give the question in a second. Draw a table, find the rule, and formula. So it'll be like 4 different aspects to the same question. But of course, we need what the actual pattern is. Let's have a look. These lines are matchsticks. And so on and so forth. So there's 4 parts to this question. Could come up. First thing, draw the next shape. Discuss, Maxim, what you think that might be.
You would add 2 more just to the top part of the next shape.
Okay, so you're noticing a pattern there, and you've created the next shape. Very good. So 2 more. So instead of the dots, I can now put in 2 more. 1, 2, 3, 4, 5. Many matches. So that's the same. So what I do is I use the same shape. I notice that they've always added an extra 2. So 1, 2 here, extra 2 there. So I put in an extra 2. Just make that the way it was. Extra 2. Perfect. That'll be the next drawing of shape. And you could continue that pattern on and on and on. But we don't want to do that. We want to shorten this down to eventually find a formula for this sequence of matchstick patterns. In order to do that, I need to draw a table. Hopefully you remember these. Don't draw the table yet because we're going to take a note on it. What's our 2 lines? What's up here? Bastian. Shapes. Okay. So I would say shape number. Define shape number, and I'm going to call that a letter then.
X.
Usually X, yeah. Shape number X. What goes down here then?
Y.
Y, okay. You've defined the letter, and what are we going to count? Bastian again? Matches, yeah. So this would be shape number 1, 2, 3, and 4. And now we need to count the matches to match. So we got 1, 2, 3, 4. Now in the exam, I would probably give you a template table that you just fill in. You don't have to get out the ruler, but you should be able to draw one. How many matches in the first shape? 3. Second shape? 5, then 7, then 9. Just count the matches. 1, 2, 3, from here. 1, 2, 3, 4, 5. I know it's a bad diagram here. 5, and so on. I know you're way ahead of me. Okay, so that's part 1. Part A is done here, drawing the next shape. Part B is this table. That's it. You've done it. Part C then has to find the rule. That's always off the outputs. These are the outputs. And yeah, you have it, Charlie. And it's all about noticing how many matches. And Charlie's already said it. And I know Maxim is going to say it. Maxim, I'll ask you for the formula in a second. You look at the pattern that you see, how many additional matches are each time. And it's adding 2 each time. So therefore, my rule is add 2 matches. It doesn't need to be more complicated than that. I notice that there's 2 more matches every time, so that's my rule. Add 2 matches. And now I come to the most important part, and I'll put it up here. Formula. Part D. All this is leading us to one place, hopefully. That is a formula, the algebraic part. Because I don't want to continue to have to draw a table or just use a rule. I want to be able to find that if I did 1,000 of these matchsticks shapes, how many matchsticks would I need to make 1,000 if I was making a massive Eiffel Tower type structure? How many matches would I need to buy? And I don't want to keep adding. I want to get there straight away. Maxim, what's my formula?
The formula is x times 2 plus 1.
Y is equal to x times 2, so I can say 2x for that. Plus 1.
Because if you look at the first one, it's the number itself times 2 plus 1.
Yeah.
And then 2 times 2 is 4 plus 1.
It's all about what you notice, yeah, and you've noticed it there. If I see a repeated addition of 2, in maths I don't repeat addition, I multiply instead. So that's why I multiply by 2 instead of saying add 2 this many times. I just multiply by 2. So if I notice this was plus 3, I would multiply by 3 in the formula, 3x. Plus 4, 4x. And then I need to figure out how far away from the answers I am. So if I multiply 1 by 2, I just get 2, not 3. 2 by 2, I get 4, not 5. 3 by 2, I get 6, not 7. 4 by 2, I get 8, not 9. So I'm always just 1 away, so I add the 1. That's my formula. Okay, and there's going to be a question like that. So you just continue the pattern, fill the table, state the rule, and then create the formula. You can always test the formula then at any stage. For the fourth shape, when x is 4, 4 times 2 plus 1 gives 9. It works. How many matchsticks are in the 1,000 shape? I was building the Eiffel Tower out of these. How many matchsticks are in the 1,000 shape? Maxim?
2001.
2001. Very good. So if I was building the Eiffel Tower out of matchsticks, 2001 matchsticks I would need, and that's purely an estimation. Maybe we should do that later on in the year. Do geometry. All right. So now I've created a formula. Now I'm going to look at number patterns. And this is a brief one. So number patterns. Numbers and create the formula. So I don't have the pattern yet. I'll put it in now. So the pattern, let's go with 2, 6, 10, 14, and it continues on.
This one is basically just the table one, but without the shapes, and it already gives you basically the rule.
It does. So this, we can use any method to find the formula. You can draw another table if you wish. So this is the first term, second term, third term, fourth term, and so on. And that will help us form the formula, because this will be our x's. This is our y's. But the first thing we need to do is just find the next two terms. Oof. Manuel, what's the next term? 2, 6, 10, 14, 18. The one after that, 22. Exactly. So the next two terms, next two numbers. How did you get that, Manuel? Always adding 4. 18, 22. And by saying that, the rule is add 4. If the rule is add 4, what must be in the formula? 4x. Y is equal to 4x. That's my starting point in the formula. These outputs, y is equal to 4x. Okay. How far away from my answers is 4x? 4 times 1 gives 4, not 2. Always minus 2. 4 times 2 gives 8, not 6. So I got to subtract 2 in my formula. I'll test that for the fourth one. 4 times 4, 16. Take away 2. Yes, gives 14. Awesome. Done. Another. Yes. And we've one more to do, and then that's pretty much everything that can come up in the exam. Now, these questions come up at certain different levels. The formulas won't be much harder than this. They might actually be easier, but maybe the factorizing and the solving equations, some simplifying might be a bit more difficult. Last one, number 7. Substitution into formulas. This is where you're given what the values of the letters are. So for instance, A is 7 and B is -3. And they ask you to find or evaluate value 8. All right. 2B plus 3A. That's an example. Let's do 2. That's part A, part B. Let's do AB minus A squared. This is the last. You're writing notes on this. This is your last note. Good news. Great. Let's do the first one. So at the end of this, we'll just have a number. Because we know what A and B are, we don't have to solve anything. We just need to figure out what the number is. The value of 3B or 2B's plus 3A's. Now, for a bit of working out here, if you're doing the exam and you want the temp marks, show the substitution. In other words, this is my question, 2B plus 3A. To show the substitution, do 2 brackets. B is -3. So replace the letter in brackets with the number value of it. And 3 times A is no longer A. You've just been given its value, it is 7. If you get the question wrong and you write this line, you get a temp mark. If you get the question wrong and you write nothing and you just figure it out in your head, you get no marks. So it might be a good idea to do this. I can figure this out then. Did anyone figure out the answer yet? Oliver, what'd you get? Yeah. 15. 2 times -3. So remember, brackets means multiply. 2 multiplied by -3. 3 multiplied by 7. That gives -6. 3 times 7 is 21. 21 take away 6 or minus 6 add 21, they both give the same answer, and that's positive 15. Part B I'll do here. AB minus A squared. Maximum, do you have an answer for this?
AB is just.
Oh no, final answer. No, you don't have it yet. Okay.
Oh, yeah.
What's the final answer?
Is.
Oh, you don't. Oliver? 28?
Yeah, 28, yeah, 28. Because it's minus 21.
Okay.
49.
Okay. Well, let's see. A times B. So I write that 7 times negative 3 minus A squared, which is 7 squared.
I can just write 7 times minus 3. But.
I could, yeah. Yeah, if you want to write the times sign, you can. 7 times minus 3, so remember that's a multiplication. 7 times minus 3 minus 21. Minus 7 squared. Okay? Yeah. 49. You got it wrong, Maxim, yeah.
Yeah, it is 7.
It is minus 70.
It's minus 49.
Minus 21. Go further back, another 49, you get minus 70. That's your final answer. So for substitution, your answer should just be a number at the end. No more letters for substitution. All right.